Vielen Dank. So, guten Abend. Mein Name ist Jorge und das ist alles that I can say in German. Well, that's not actually true. I was living here for 6 months, but my German is really, really rusty. So I know how hard it is to be in a conference and how tiring it is. So I really appreciate that you came here for listening to my talk. I hope it's not going to deceive you. I know as an experience that if you do the last talk, particularly the one before the beers, you either have to be really amusing or interesting. I'm not amusing, so I will try to be interesting. And I will try to talk about the topic that I told you in the name of the talk, which is mostly about architecture and how to apply some of the features that Kotlin offers to you when implementing an advanced architecture. But before I start with that, I think I should give you a little bit of context, because even though I am flattered because of this attendance, I'm pretty sure that most of you don't know a word about who I am. So, and what I do. And what I do is mostly help companies and individuals to learn about best practices and architecture. So I organize myself as a freelance, and I work for third parties, for companies who hire me to improve their architecture, consultancy, or to train their developers to create a better architecture. And I do that for both iOS and Android. Okay? So I do this for Swift and Objective-C, and I do this also for Java and Kotlin. So what I'm going to share with you is what I have learned when I started creating the materials and the first editions that I did with Kotlin. So let's start without any further ado, and let's talk about what I mean by this home improvement. And as I said, it is a way to go a little bit beyond of what made you successful. Usually, companies create an architecture, they create something that provides business, fulfills the business purposes as they were initially decided that they were relevant. But usually your company, if it is successful, it grows further. And then you have an application that then you try to add an additional feature, and you touch here and it breaks there, you touch there and it breaks here, and it's a nightmare to maintain this application, to make it grow, to add more features, to keep with the business. So, as I said, I was creating these materials, which I use for training people, and I had the materials in Objective-C, in Swift, and in Java. And I remember very clearly that I attended as a speaker the droidCon in Madrid 2.5 years ago. And I was the speaker for the conference teaching testing, unit testing. But that conference, the hot topic on that conference was what was going to be the language that Google was going to take to overcome the problems with Java. Java was stagnated. They were only allowing us to use Java 6, and we wanted to take advantage of some of the things that other platforms had. And in order to do that, there were different answers on stage. Obviously, the decision was not taken based on the talks that were happening there, but it provided me with a lot of insights on things that could be interesting to check. At the time, I remember I attended some talks about Scala, very nice language, about Go, about Dart, and I remember Antonio's talk, Antonio Leiva, probably you know his book, about Kotlin. And I thought, oh, this looks like a nice language. I should try to test that one, and I should try to apply the techniques that I have known to have a good architecture and use Kotlin for that. So I created the first version of the repo that I give to my customers in Kotlin, and it was as bad as my German, which means that I was roughly translating word by word from Java to something that I called Kotlin, but to be honest, it wasn't. I have done a couple of iterations more, and every time I have learned a lot by doing that. I create a full application from scratch, and I do every kind of scenario in the application. So that means that I write a little bit of code to do that. Still, I must say that all the things that I'm going to tell you now are based on my personal experience. And as you know, the Kotlin community is not young, but the Kotlin community with the approval, with the seal of approval from Google, it's very young. It's in its early stages. And some of the things that I may say here may not be what you think about that. And I will be glad to listen otherwise, okay? But my opinions on these languages, on this language, are still in the construction. Some of the idioms are not there for me. Some of the things that I will show you, maybe in a year, I will decide that there's a better way that I didn't know at the time to do that. Still, I'm brave enough to come in front of all of you that probably know far more than me about Android development, and I'm going to share what I have learned. So I hope you like it. Before moving on to that, let me cover the 3 topics that I'm going to talk about today. The first one is a little bit about architecture. And obviously, this cannot be a very long introduction because this is a 45-minute talk, and I also want to cover Kotlin and how it applies to that architecture. But I want to give you at least the basic ideas that we can all share, so when I'm referring to some part of the architecture, you know what I'm talking about. Then I will talk about some usages of Kotlin for the application of this architecture in Android. And I will give you different examples for that. And finally, I will do a brief recap. So if you want to sleep, you have to sleep from now till the recap, okay? Okay, let's talk about architecture. The architecture that I'm referring to when I talk about advanced architecture is roughly based on Uncle Bob's clean architecture. But because I want to know the audience, and I want to know if I talk to you about a presenter that you know what I'm referring to, let me briefly ask you. Who has implemented or uses every day model view presenter? Yeah, a lot of hands here. Model view model. Cool. Clean architecture, Viperish, or something like that. Okay, cool. I'm not asking about model view controller because this is not an iOS room. In an Android, it would be putting everything in the activity but the database, okay? So let's forget about that and let's go with the clean architecture. For those who haven't learned anything about the clean architecture, this is going to be a very brief introduction, but I think that is going to be enough to keep you interested and read a little bit more from Uncle Bob or somebody else that can tell you about that. The clean architecture is strongly based on 2 previous architectures, the Onion architecture and the ports and adapter. The basic idea behind the clean architecture is centered around the data and the business logic. So what is the most important part of your application? The UI, the buttons, the animations? No. That's not what feeds you. That's not what brings money to the table. It makes appealing the application to the user, but the business logic, the business cases, the use cases that you sell to your customers is what is important about your application, and more importantly, is what is most immutable. The thing that you want to keep unchanged even though the new release of Android O, is there, okay? So then you have these inner layers, the white one, which is the data, the entities, the red one, which is the use cases, the interactors, and then surrounding this, you have another layer, the green one, which has the presenters and the repository patterns that you use to access your data, and things like that, abstractions to other stuff. In the outer layer, in the blue one, you have everything that is considered an implementation detail, which is a very polite way to dismiss something. This is like uninteresting. This is an implementation detail, okay? And these are implementation details because your application, the business logic of your application should be same dependently on whether you are using an Android interface or using a web application, okay? The business logic behind that should be similar or in the best state equal, okay? And notice that in this picture there is an arrow, a yellow arrow there, and this yellow arrow is the dependency rule, and this is key. It is very important that when you implement an application like this, with this architecture, everything that is in an outer layer can depend on something in an inner layer. But anything that is in an inner layer cannot have any dependency whatsoever on an outer layer. Well, that seems really, really hard because, I mean, like, you have to talk to the outer layers, you have to bring the data and display it on the views. So how do you do that? Well, you use the dependency inversion principle. The dependency inversion principle says that if I want to use a class and make it independent, I have the high-level code should not depend on low-level code. So my business logic should not depend on the way that I have decided to implement my persistence. If I'm using content providers now or tomorrow I want to change it to a network API, I would like to be able to change that without having to change my business logic. So I remove this dependency and instead I define an abstraction. This abstraction is what I will depend on. It's an interface or an abstract class. And depending on that, instead of the detail, the implementation detail, I am totally independent on these actual libraries. Instead, what I do is I create the glue code that will connect the abstraction that I define with the library that I'm using, the persistence or the API or anything, any implementation detail that I'm using. Do you like this implementation? Do you think that it provides you with a good architecture? Well, what I'm going to say now is tough. But I would like to take advantage of this room and make a very respectful criticism about some opinionated decisions. Probably all of you have heard about the Google I/O, the recent Google I/O, and the architecture components that Google released at that time. And I think that that is an awesome job. It's great that we finally have a document that talks about architecture and that spreads the knowledge among all of us Android developers. However, the way they have implemented this, even though it's a good starting point, if you were putting everything inside of the activity, it has a problem. Your view models have a dependency on the SDK, which is in an outer layer. So if you want to go with a clean architecture, architectural components, maybe not there, okay? My opinion on that. But I will be glad to discuss that during beers later, probably before the beers, okay? So if this is what we all agree that could be the basic blueprints for an architecture, how does Kotlin help me with that? Well, Kotlin brings a couple of things to the table, several, and I'm not going to be able to cover all of them, but I think I want to cover a few. The first one would be the conciseness, the terse language that we got with Kotlin. Second one will be about the data classes. Then we will talk a little bit about extensions, a little bit about property delegation, and finally, some hints about sealed classes. Let's start with conciseness. And well, conciseness is important because we want to have code that can be easily read. And we know, since we were very, very young, that the more words it has, the longer it takes to read. And you know that code is not meant for computers to be read, but for our colleagues and ourselves in a few hours to be read and understood, which means that the terser the code is, the better it is for us because we will read it better. The code that you have there is just a very simple example of a module for Dagger 2, okay? This is written in Java, and yes, I said that I was going to show you Kotlin code, but I want to compare it with something. So this is the Java code, and this is the Kotlin code. Very similar, but notice the difference in font size. And this is because, well, it's terse. I mean, the main difference here is that when you see the Kotlin code, you have this nice applied method that allows me to get rid of the object that is being called every time. And we have these equals that allows me to use an expression instead of the body of scope of a function in order to be using that. And probably you're thinking, well, that's not much. I mean, like, this doesn't help me much in terms of everyday's code. Well, a couple of lines, a few more here, are really relevant in terms of being productive. And it is not only important in terms of that, it's important to have code that can be read more easily. And this applies not only to the regular code, but also to the code that you write in order to test. This is a test case that we have for testing a presenter with the data, a use case, sorry, with the data to see if it goes to the presenter. If there is no data or is the name passed to the presenter. This is a very simple unit test using Mockito and using Java. I have to define an array with the fixture data that I'm going to use and to check that the data is passed properly to the presenter. What do I do here? Same thing in Kotlin. But because the way I apply the capture there is nicer, I need less code. Also with the arrays. You know that probably all of you answered the questionnaire from JetBrains asking what was the feature that you wanted the most for the next version. Who answered here, I want to have literals for arrays? Nobody? Well, I did. And the list of probably will become something shorter in the future. So, well, that is not much. I mean, it's only a few words, more readable, nicer. So what do I have with data classes? Well, I told you that the architecture was meant around the data, around pollos, in this case, pocos, because we're talking about Kotlin. So how do data classes help me with that? Well, data classes are really helpful because instead of having to define all the properties, the fields, the getters, the setters, and also to create, even though it is generated, a hash code function, a equals to function, a toString function, I don't have to do anything of that. I can go with the data class, define the attributes of this data class, and they will come here, and I have a constructor generated by default, and all these methods that I mentioned are also generated by default. I can even add some additional functionality, like the one that I have here, that is a computed property. This computed property will be generated based on the logic that I have added to that entity. So having an entity here, well, it is several lines because of the size of the code, but this could be a 2-liners or 3-liners. So very nice. But one of the limitations of data classes is that they are not value types. You know that. I mean, there's a big difference between having a value type and a reference. And Kotlin, so far, we will have to wait till Project Valhalla is ready, but so far it's only able to have references. So this is not a value type, which has some limitations in terms of concurrency and how we use this data class. Another thing that gets in the way is because of this nice constructor that has been generated to you, you have a limitation in terms of defensive copying. Who knows about defensive copying here? Defensive copying? Nobody? Okay, so let me explain what the problem is, because, sorry, I said nobody, but I saw your hand. So there is a book that is called Effective Java by Bloch. Is Joshua Bloch is the name of the guy? So really good book, even though it is 2005-ish. I recommend you to read it. It's still valid. Not every item of the book, but like 95% of the book is very interesting. And the book tells you that sometimes, I mean, like if you want to defend yourself against the use of your class, of your Pojo, you have to make copies of the objects that are used in your constructor. So imagine that you have a date as one of the fields of your data, of your Pojo. If I get the date as a reference, and that object, the reference that was created outside of my constructor, is modified because I'm pointing to the same reference, my actual value of the date will be changed. That's bad. Not only that, if I give you a reference to the date that I have, and you change that because we are changing the same reference, I also have my value change inside of my class. Really bad. So defensive copying is avoiding that problem. Copying what you get in, copying what you provide out. Okay? And the constructor in Kotlin gets a little bit in the way. I've seen many references. I even asked my friend Paco. Paco works for those who follow his Twitter about a solution because he has more experience with Kotlin than I do. And he gave me one with an underscore in the field for the constructor and providing another property that was private. I'm sorry. I'm like, I have written Swift too. And one of the differences between Kotlin and Swift is that in Swift, you do have to use the parameters names. In Kotlin, they are optional, which is good and bad. It's good because you can ignore them when you don't need them, but it's bad because things like having two constructors with the same types is impossible because the compiler is not able to differentiate the two types. So what I did was this construction, which makes the constructor private, uses another property, and creates a companion object that provides you a factory method to create a new instance. Then I can have a customized getter and setter that will give you or obtain the copy when it is provided from the outside. That the name of the property that is seen from the outside is the date without the underscore. The one that is used in the inside is the one with the underscore. So I'm using a backing property, which is a little bit harder from the perspective of generated data class. Okay. Extensions. Extensions is a very nice feature of Kotlin. And probably all of us have had at one time this package which has util classes that are very useful. But we have created these classes because we couldn't put the code in their original class, which is a limitation. That is very useful for things like presentation logic in an advanced architecture. When I'm talking about presentation logic, I'm not talking about business logic, but the things that I have to do in order to change the object to show it to the user. For example, I have a temperature. Based on the configuration of the user, I may decide to present it in Celsius or Fahrenheit. I have a to-do app. Do I provide the raw date, or is it better for me to provide in 2 days, tomorrow? It's more telling to the user. So that is presentation logic. The data is the same. What changes is what I do to the data in order to show it to the user, but the data is not changing. So in this case, I can take advantage of an extension and have this extension provide this method that provides a relative string based on the content of the date and another one that is the reference. Okay? Very simple, but it helps me to move presentation logic. It is still bounded to the date class, and it is in the package for the presenter. Okay? But there are a couple of limitations of extensions in Kotlin. One that is really pissing me off is that you cannot implement an interface by implementing the methods in extensions, which is a pain. I know that this is a limitation of the JVM, but sorry, I want that. I'm like, if I create an interface that has the method present and the interface is called presentable, if I add the extension to an object that adds the method present, I want this object to be presentable because it has the method. But it cannot be done, at least that I know of. If anybody knows, please let me know. That is a limitation. Another thing that is, well, I'm picky, a little bit snobby, but the thing is that I would prefer to have all the extensions in a scope instead of all of them separated individually. So I have to go extension by extension and create like one per method. Ugly. Not only that, it's not only ugly for me, it's ugly for the IDE also, because if I create a file for those, it says like, oh, this is not a class, this is not an interface, it's a file. A file of what? So the interface is, the IDE is not classifying this file properly either. Property delegation. That is a very cool feature of Kotlin. Really powerful. Probably you have heard some examples like this one. And here, what I'm doing is I have a presenter and I have a request, something that is going to hold the data while it is being changed in the user interface. And then when I have the data ready, I will put it into a use case and run the use case, okay? This presenter is the data class that I show you up there in the first line, okay? In this case, it's very simple. It has a name and the number of units for a product. Very simple use case, okay? But please notice that I have there what is the by, that is the keyword to imply that this property is delegated to this object, to delegates observable with this initial value. What I'm telling is, okay, when you have a change, invoke this method. I can ignore the three parameters that are passed to that lambda. Notice that if you run this, if you change this request per property, the method will not be triggered. Why? Because the reference to the object is not changing. What it is changing is one of its properties. So in order to be able to trigger the delegation, you have to go and change the reference, create a new request with new data, or monitor individual properties individually. Okay? Still, very, very nice. Really, really powerful. Not only for that, you can have, you can have this other implementation, which I haven't seen anywhere. That is, maybe you want to have a weak reference from the presenter to the view. Let's say that you want to survive the configuration changes. And when you have this reference to the view, you want this reference to be weak in case you want to delete it. So you declare this class here that, as you see, is a generic class, and you say to every reference, to every property that you want to be weak, that you use this delegation. That is going to be an optional, and it's going to be using this delegate, and it will take care of this. It will take care of wrapping the reference and providing you with a null value if nothing is there. Really useful in an advanced architecture, because this is a piece that gets created and reused as much as you need it. Code utilization is key in a good architecture. Sealed classes. Okay. I see many seasoned Android developers here. So probably you all know that enums are considered harmful. Nobody's complaining, so I assume that's a yes. And the reason why it is considered harmful is because of that message that appear and disappear about don't use enums, okay? But if you go and do a little bit more of research, you will find out that there are a couple of reasons why enums are considered harmful. The first one is space-wise. I mean, like, if you were going to use, for example, an integer, it only takes the number of bytes of an integer. While if you are holding a reference to the class that contains the enums value, it takes more space in memory and also in storage. That is one. The second one is that it is also relevant in terms of performance, because now, in order to access one of the values, you have to go through the getter of that object in order to get the value that you are using for that case. So that is why it is not recommended to have a reference. Is a question? Oh. So that is a reference to the two reasons why it is not recommended to have enums. The same thing applies to SIL classes if you are using them in a when. For those who don't write Kotlin, a switch, Kotlin, switch, okay? If you use a when, if you use SIL classes only for the purpose of going through different use cases in the switch, in the when, then that is not the best option, okay? However, so don't do this. Notice that I have put an star up there, meaning not that this is something that should not be done, but the code that I wrote there should be avoided if this is the only thing that you are doing with the SIL classes. If you are doing something else, if you are taking advantage of the SIL classes for some other attributes of the SIL class, then go with it. I mean, SIL classes are algebraic data types, which is like saying I have a kind of objects that are somehow different, and then they can behave differently, and they can take different parameters in their nature and number, and I want to use them similarly. And the number of cases that I have are a fixed number of cases. So this is what you use SIL classes for. The typical example is to provide back a result. So you have two cases there. If everything is successful, I will return the generic value that you asked me for. If everything went wrong, this is completely different, then I will provide you with an error. So by just returning something, I will give you the two possibilities. It's like an optional. I can either have null or have some value. So this is what SIL classes are for. Okay, so I hope that you have found anything interesting in the cases that I mentioned about Kotlin, about usages for the architecture, because I'm going to recap. And I will take questions and answers after that. So, very briefly, I think that my experience is that writing the same code in Kotlin or Java, it is far easier to do it in Kotlin than it is in Java to write exactly the same application. Obviously, far easier means that you already have some experience writing it. The first time I did it, it was painful, like every time that you wrote code in a new language. But after the first iteration, it is a sweet language. It is very fluid. You can get a lot out of it. You don't need to write a lot of code. Some things are very easy to do. You can have top-level functions. Imagine that you write Mockito handcrest matchers. So if you want to have handcrest matchers, usually you create a class to put the methods there that will be the matchers. But that class is totally unneeded. They are static methods, and you don't need anything there. Another thing that you could avoid by using Kotlin, you can have top-level functions, and the matchers can be top-level functions. Okay? So it provides you with a lot of help in terms of having that. I don't know, to be honest, if the companion objects is the best idea for static methods. But even though that is the case, I think I really like the language compared to Java. In terms of the things that we have mentioned, I told you when to use something and when not to. My advice on that, I can be wrong, but still I gave you my reasoning on why some of the stuff is worth to be used and some of the stuff is not. So learn your options, do your research, check whether something works or not, and choose what is worth for you to have in your implementations. And as I said at the beginning, we're still learning. I mean, like, Kotlin in the Android world is very young. So there are some things that we are writing now and we are proud of ourselves that will be our shame in the near future. At least they will be mine because I put them here and there was going to be recorded and you will be seeing them in a future that is not so distant. So in any case, this is a moving target, so please adapt to the newest version of this. Vielen Dank. So thank you very much. I will take questions now. If there's any, if the question is, can I go and have beer? Don't ask it. Just go. Any questions?